Good day. We'll discuss the Term 1 Past Year in 2021, question 16. We have an object P of mass 0.025 kg is released from rest and slide down on the smooth curved track to the mass and make a head-on collision with an identical object. So it means that the Q also has the same mass as P. So what can we see here is that the P is released at height of 18 centimeter. So make sure to convert the unit from the mass, and the velocity of Q after the collision is 1.41 meter per second. So the first question is to calculate the velocity of P before it collides with Q. So it's involved about the energy of conservation since it is slide down on a smooth curved track. So what we can see is the gravitational potential energy will be converted to the kinetic energy at the base. So we have the mg delta h equal to half mv delta v squared. So since it is released from rest, so it has a zero initial velocity. So what we can see here is that we can quickly get the mv squared, half mv squared minus 0, okay, for the initial kinetic energy. So we can proceed to solve the question. We can cancel the m here. So what we have is the g, 9.81, multiply the delta h, 0.18 meter. And then we have half v squared. So the rest is just calculations. To obtain the velocity, what we do is just 9.81 multiply 0.18 multiply 2, and then what we do is square root the answer, and you get the final velocity is 1.88 meter per second. We move on to the next question. Calculate the velocity of P after the collision. So this is about the conservation of momentum after the collision. So we just apply the formula that the total initial momentum is equal to the total final momentum. So we have mpup plus 0. Okay, 0 is the momentum of Q since it is at rest. So it has a 0 momentum initially. And then we have mpbp plus mqbq. So just put in all the values. And we have the mass of P and Q is 0.025 kg. So actually they have the same mass, so I think we can just cancel all the m here. Okay, and then we have the initial velocity of P is equal to the final velocity of P plus the final velocity of Q. Okay, a simpler calculation. Okay, so we have 1.88 is equal to the velocity of P, and then we have the final velocity of Q after the collision is 1.41. So the velocity of P would be equal to about 0.47 meter per second. We proceed to the last question. Determine the type of collision. 3 marks. So at first, I also suspect that this is an elastic collision since the velocity of both objects are different. But since this question gives us 3 marks, so I guess we should do further investigation on the question. So to differentiate between elastic and non-elastic collision, one of the most obvious criteria is about the conservation of the kinetic energy. So let's check if the kinetic energy is conserved in this case. So what we have is the initial kinetic energy. So let's check. So we have half mup squared. Okay, so that's the initial kinetic energy of P before the collision. So just put in the value, we have half. Okay, multiply the mass. Okay, so the initial kinetic energy is about 0.44 joule. Then we're going to check the final kinetic energy. Okay, the final kinetic energy. So that will be half m, the final velocity of P squared plus the final velocity of Q squared. So just do the calculation, 0.5 times 0.025. So we can see that the final velocity is only 0.028 joule. So this means that there is loss in kinetic energy. So I guess it is an inelastic collision. So since there is loss in kinetic energy after the collision, it is an inelastic collision. So that's all for this question, and thank you for watching.